Hi, my name is Paul and welcome to the DocIT channel. Today we're going to start our new tutorial about HDFS. In this video we're going to discuss such topics like as what is HDFS, why HDFS, we're going to talk about architecture, about rack awareness, and of course about features of HDFS. So just imagine that you've got a small business and you've got an application. The all data located in our server, and this is only one server you have. All clients try to connect to this server, but what do you think? What's going on if this server will break down? Your application will be destroyed and you will lose all your clients' data. And of course you're gonna be unhappy. After this you will try to resolve this problem and you're gonna use HDFS for saving your data. So what is HDFS? HDFS, it is Hadoop distributed file system. When a dataset exceeds the storage capacity of a single machine, that it becomes mandatory to partition the dataset across several separate machines. The file system that manages the data across the network of machines is called a distributed file system. A distributed file system is a file system that allows us to store data across multiple machines or nodes in a cluster and allows multiple users to access data. Since that distributed file system is based on the network, all the complications of network programming kick in, making a distributed file system more complex than a regular file system. One of the biggest challenges in the distributed file system is to tolerate node failure without suffering data loss. HDFS follows master-slave architecture. The HDFS consists of two types of nodes that are master node and slave nodes. The master node manages the file system namespace. That is, it stores the metadata about the blocks of files. The slave nodes store the user data and are responsible for processing data based on the instruction from the master node. The master in HDFS is the centerpiece of HDFS. There are high-end machines and store data metadata related to all the files stored in HDFS. It manages and maintains the file system namespaces and provides instruction to the slave nodes. The NameNode is the master node in the Hadoop distributed file system. Slave nodes are responsible for storing the actual business data, but their normal configuration machines that stores and processed the datasets upon instruction from the master node. The data nodes are the slave nodes in HDFS. NameNode is the master node. It manages file system namespace operation like opening, closing, renaming files and directories. NameNode maps data blocks to DataNodes and records each change made to file system namespace. DataNodes are the slave node that handle read-write requests from HDFS clients. DataNodes creates, deletes, creates and replicates data blocks as per the instruction from the governing NameNode. HDFS split the files into block-sized chunks called data blocks. These blocks are stored across multiple data nodes in the cluster. The default block size is 128 megabytes. We can configure the default block size depending on the cluster configuration. Also, HDFS creates replicas of blocks based on the replication factor, a number that defines the total copies of a block of a file. By default, the replication factor is 3. It means that 3 copies of each block are created and stored across multiple nodes. If any of the data nodes fails, that block is fetched from the other data node containing containing a replica of a block that makes HDFS fault tolerance. So let's talk about important features in the Hadoop HDFS. First of all, it is high availability, then fault tolerance, high reliability, replication, scalability, and distributed storage. So let's talk about high availability. In this file system, data gets replicated among the nodes in the Hadoop cluster by creating a replica of the blocks on the other slaves present on the HDFS cluster. So whatever a user wants to access this data, they can access their data from the slaves which contain its blocks. Fault tolerance. Fault tolerance in Hadoop HDFS is working state of the system in unfavorable conditions. It is high fault tolerant. Hadoop frameworks divides data into blocks. After that, it creates multiple copies of blocks on different machines in the cluster. So when any machines in the cluster goes down, then a client can easily access their data from the other machine, which contains the same copy of data blocks. Replication. Data replication is a unique feature of HDFS. Replication solves the problem of the data loss in unfavorable conditions like hardware failure, creation of node, or others. HDFS maintains the process of replication at a regular interval of time. It also keeps creating replicas of the user data and different machines present in the cluster. So, when any node goes down the cluster, the user can access the data from the other machines. Thus, this is not possibly of losing of user data. As you can see on the picture, we have a green blocks that are replicated on the three data nodes: DataNode 1, DataNode 2, and DataNode 4. If the DataNode 1 goes down, the user can read this file from the DataNode 2 and 4. Rack awareness in HDFS. Hadoop HDFS stores data across the cluster of commodity hardware. To provide fault tolerance, replicas of blocks are created and stored on different data nodes. NameNode places the replicas of blocks on multiple data nodes by following the rack awareness algorithm to ensure no data loss, even the data node or the whole rack goes down. The NameNode placed the first replica on the nearest data node. It stores the second replica on different NameNode on the same rack, and third replica on different data node on a different rack, but in the same data center. If the replication factor is 2, then it places the second replica on the different data node on a different rack, so that if a completed rack goes down, then also the system will be highly available. The main purpose of the rack awareness replica placement policy is to improve fault tolerance, data reliability, and availability. So, in summary, we can say that Hadoop HDFS is highly reliable, fault tolerant, and highly available storage system known to date. It follows the master-slave architecture, where the NameNode is the master node and the DataNode is the slave node. Also, HDFS splits the client's input file into blocks of size 128 MB, which we can configure as per our requirements. It also stores replicas of blocks to provide fault tolerance. NameNode follows rack awareness policy for placing replicas on DataNode to ensure that no data is lost during machine failure or hardware failure. In addition, the DataNode sends a heartbeat message to NameNode to ensure that they are alive. Guys, thank you for watching this video till the end. Please subscribe to the channel and like this video. For you it's just a few seconds, but for me it's really good motivation to continue create such videos like this.